Hello, nice to meet you. My name is Il Seo from Midas headquarters in Korea. I'm a senior technical manager for nGen. This will be one of many webinars for this year for nGen. I'll be talking about 4 topics as you can see on the screen. The first topic is the nGen Revit interface. The second is the use of mesh mode. The third is automatic structural drawing generation in nGen. And the final topic is for the UK National Annex. I'll start with the link between nGen and Revit structure. nGen link for Revit structure enables us to transfer Revit data to Midas nGen directly and deliver it back to Revit for building information technology, or also known as BIM. For compatibility with Revit structure, Midas nGen data is converted into a text file for both ways. This function is provided as an add-in module in nGen. Midas link for Revit structure supports the following workflows. The first step is to send the analytical model of Revit structure to Midas nGen. The second step is to import the JSON file of the Revit model in the Midas nGen. The third step is to export the model of nGen to JSON file. The fourth and the last step is to import JSON file in Revit structure as an analytical model. You can import or export the model data easily. The following table shows which structural members can be shared between Midas nGen and Revit structure, and how it works in each program. The model properties such as grid, level, information, material, and section can be transferred in both directions, and most member data can also be transferred in both directions. However, nGen's isolated footing and strip footing data cannot be imported in Revit. Also, when importing Revit data in nGen, the model is converted into mat footing type. Revit structure provides the concept of a family format in the truss structures, but when imported into nGen, it becomes individual brace members instead of the original format. Offset information does not need to be considered because both nGen and Revit have automatic shape offset functions. The rebar interface features have been developed in this release version. Here's an example I'll demonstrate today regarding the nGen link for Revit. First, 3 grids exist for both directions at each level, and the model has 9 columns, 4 braces, 12 beams, 4 slabs, 2 walls, 1 foundation, and additional openings. Okay, let's run it. As described above, it's a model with multiple levels, grids, and various structural members. After installing nGen link for Revit, I'll find and run export to nGen in the add-in. A dialog box for exporting information opens as follows. Check whether there are any abnormalities in the number of the unit, export item, and export member. In the case of materials, the value set in Revit is passed to nGen as it is. In the case of section, it's automatically matched to database in nGen. However, it's necessary to check whether it's imported accurately, and if you find any errors or wrong information, you should manually assign it. I'm going to explain how to assign section directly. When the DB section is selected, one can set the DB code and section dimension. When the user section is selected, the section dimension setting is completed by matching the dimension parameters. After mapping all sections, click OK and save it as a JSON file. And load the JSON file in nGen. You should check the number of data in the model in the import dialog box. You can check the grid and level information and change the member type if necessary. If there's no problem, click OK and you can figure out that the model has been imported successfully. Next, let's export from nGen to Revit. The same model will be used. First, we'll export an nGen data as JSON file. Select the information to be exported and click OK and save it as a JSON file. Then run import from nGen in Revit's add-in. Since it starts with a new project, first enter the project name and then load the saved JSON file. The information dialog box opens in the same way as when importing. Check information and carry out the mapping of materials and sections. Materials are assigned automatically, but in the case of sections, you must assign them yourself. To allocate a section, you need to load the family DB for the section. I'll import the family DB for the L angle section from the English folder. When loading is complete, select ML angle from the family name and then select the section list. Next, I'll bring H-shapes family DB. Assign the section of the imported family. If necessary, you can select and assign a different section. I'll import and assign the same family DB again. Next is the column. The columns are grouped into separate folders. In the same way, I'll bring the H-shaped DB and allocate it. If you finish section mapping and click OK, you can figure out that the model has been imported successfully. If you do not have a section family, you can download it from the Revit homepage, Revit website below. The address is as follows, and DB is provided for each country as follows. Next, I'll introduce about how to export the rebar information of nGen to Revit. First, before exporting the rebar information, the development and splice length should be set. For each member type, you can enter lengths for tension and compression respectively. The created Excel data can be pasted in these tables, and automatic calculation is supported for Eurocode. Next, the rebar shape should be defined by member type. For the end shape of rebar, nGen provides 4 basic shapes for type 1 to type 4, and for stirrup, provided 2 shapes of type 5 and type 6. In the case of a beam, the extension length of the end rebar and the separation distance from the column face of the middle rebar can be defined. The rebar details for each member are as follows. For columns and walls especially, the dowel bar can be taken into account when creating rebar information. The position of the rebar is along the local axis of member. After setting the rebar length and shape, you can export the model and rebar information as follows. The scope of support for the rebars export is as follows. Most members are supported, but not for brace types. The hook lengths use the automatic calculation provided by Revit. Here's a demonstration for a simple model. First, check whether the rebar information is input before exporting. The rebar information is entered in the example model is as follows for each member. The next step is the setup for development and splice. By clicking the tension development length, we can find the length table according to material and rebar diameter. The default is set according to Eurocode, and auto calculation for Eurocode is supported as follows. The user's edit are possible as well. Now let's set the shape of the rebar for each member. First of all, it's for the beam member, the top rebar at the end was assigned in the shape of type 2, and the bottom was assigned in the shape of type 1. The anchorage lengths can be assigned LDH, LDC, etc. according to each anchorage type. The rebar length at the end can also be selected as follows. In case of cantilever beam, the end part is set to type 4. The columns are set as follows. For columns with the footing, dowel bars can be applied. The following is the setting of the footing. Now let's export it to Revit. The rebars can be exported selectively and optionally. Enter a file name and launch Revit. Let's import nGen model, enter a new name for Revit model and select the created JSON file. The following is the dowel bar for the vertical rebars of the column and the column rebars. For stirrup and hook bars, you can edit interval distance. The following is the dowel bar for the vertical rebars in the wall and the wall rebar arrangement. Lastly, slab rebar arrangement. I'll also import other sample models. Okay, this is a model that has not yet set the anchorage shape of the rebar. Rebar arrangement is also supported for sloped slabs and as follows. Next is another sample model. By importing the rebars in the analysis model, it is expected that it will be very helpful to input and edit the rebars information in Revit. Next is the mesh mode for analysis. In the previous version, one can check the mesh quality only after performing analysis. Thus, every time the user wants to check the mesh quality, the analysis should be performed again, which is inconvenient and time-consuming. The newly introduced mesh mode provides the ability to check and modify the mesh size and shape. Besides, mesh creation errors in the pre-processing stage can be detected without analysis. If you run mesh view mode, you can check the mesh shape immediately. First of all, there is a setting dialog in mesh view mode that allows you to control the overall mesh size. Here you can set the mesh size separately for each part and determine the mesh shape. The mesh shape is categorized by triangular and square shapes as follows. Each model can be composed of only triangular elements or a mixture of quadrilateral and triangular elements. Next is the mesh size control function. This is a function for controlling the local mesh size. The first icon is used for the mesh size of the edge in 1D member or 2D member. And the next icon can control the mesh size of a 2D face by member unit. Information of mesh size is saved in the tree as shown on the right and can be edited. Finally, check mesh results. This is a function that finds errors occurred in the created mesh before performing the analysis. The first option finds cases where the mesh is created without taking into account the interference between two members. The first figure shows that the two members' meshes did not interfere with each other, and the information of the two members is provided in the check results table. The figure on the right is a case with a regular mesh shape created with considering interference. Finally, check mesh results. This is a function that finds errors occurred in the created mesh before performing the analysis. The first option finds cases where the mesh is created without taking into account the interference between two members. The first figure shows that the two members' meshes did not interfere with each other, and the information of the two members is provided in the check results table. The figure on the right is a case with a regular mesh shape created with considering interference. I'll demonstrate the mesh view mode through the sample model. Let's create a mesh set. At this time, the mesh of the model was created to have errors in purpose. If I check the displacement shape in the analysis results, I can visually confirm the problem in the connection between the members. To pinpoint elements with problems, execute the check mesh results. When I click the list, the program flashes elements as shown on the screen, so the location is easily detected. In a large percentage of this case, the problem is caused by modeling, so that modifying the model will be the solution. After modifying the model, I can confirm that the deformation shape becomes normal. And let's create various mesh shapes using mesh size control. First, we'll do size control for the edge of 1D and 2D member. Next is the control for the 2D face. Even if a very large size is entered as input, the created mesh size may be smaller than we want, since the adjacent elements also affect the creation of nodes simultaneously. Let's edit it again with a minimal value. In general, the smaller the mesh size, the more accurate results can be obtained. Therefore, applying the smaller size only in the necessary part can reduce analysis and design time. The next topic is generating a structural drawing. nGen supports the auto-generation drawings with model and design information. The procedure for drawing work is as follows. First, when performing the drawing tool inside nGen, it automatically reads the model and design information and generates 3D information internally. Based on this 3D information, the following drawings, such as plan and section drawings, are automatically generated. Midas Drawing provides the same features as AutoCAD, so you can edit and print the drawings in Midas Drawing without other drawing software. To create a drawing, first set the story or level information to be output as follows. It provides automatic setting, and you can add the level you want to create an additional drawing. When Midas Drawing is executed, first set the length of rebar development and splice and select anchorage type. In case of the development and splice lengths, you can directly modify and paste Excel data in drawing table, and auto calculation according to your code is supported also. For anchorage, straight anchorage and hook anchorage types are provided. After the basic setting, the following drawings can be output sequentially. First, overview information such as building information and material properties can be output. Next, we can create a structural plan drawings. It can be selectively generated from the floor information set in nGen. The types of floor plan are floor plan as follows. And you can create foundation plan drawings and tile layout drawings. In foundation plan, the dimension of foundation and rebar arrangement information are displayed. And in pile arrangement, distance between piles and level of pile are displayed. Finally, you can generate the rebar arrangement of slab. And if you set the position and depth of this section in the created plan drawing, you can create a section drawing from the 3D information as follows. The following is the rebar arrangement drawing for each member type. Midas Drawing supports arrangement of rebar for beam, column, and wall. You can optionally output from the automatically generated list. The following drawing is the rebar arrangement for the beam. The drawing is composed of a key plan for member location, the rebar details, and a table to know the length and quantity of reinforcing bars. Drawings for columns and walls are also configured in the same way. The following is a sample rebar arrangement drawing of wall and column. Finally, you can generate the member lists. A drawings are created for the selected drawing type as follows, and it shows the dimensions and rebar information of members in table format. Midas Drawing provides frame drawing as shown on the screen. When inserting the frame sheet in window, you can set the frame size and drawing scale. And the text size, arrow size, and hatch density are automatically converted according to the sheet scale when moving the drawing to the inside of the frame sheet. The generated drawings can be converted to DWG or DXF format and opened and edited in CAD software such as AutoCAD. You can directly customize templates applied to the generation of drawings. You can change the line color, arrow shape, text size, and color of plan drawing and section drawing. And you can customize the rebar arrangement drawing and member list in the same way. Lastly, Midas Drawing is supporting to generate the bill of material. You can find the concrete volume, steel weight, and formwork area for each member, each rebar diameter, and total sum.